So today we're going to go ahead and take a look at factoring. Now, if you follow these steps for factoring, it'll help a lot. Now, on this step one, you always want to look for a greatest common factor. That's the largest thing you can take out of everything. Do that first, no matter what. Now, in the second step, second thing you want to look for is if it has two terms. Now, if it has two terms and something squared minus something squared, then you can factor it into two parentheses that look very similar, but one's got a plus and one's got a minus. What goes in the beginning of each parenthesis is whatever's in the beginning that's being squared, which was an A. What goes in the end of each parenthesis is whatever was being squared, and that's a B. Now, when we're looking at two terms being added or two other terms being subtracted, it might be looking at two things that are cubed that are added or two things that are subtracted that are added. What goes in the beginning, or what your A corresponds to, is whatever is being cubed. Then that goes here, here, and here in the beginning. And then you look at the end, what was being cubed at the end, which was a B. So the B's go in these spots. And that's the same as it is down here for differences of cubes. Now just be aware that when you're dealing with differences of cubes, there's a couple of things that switch. And what switches is our signs. These signs are different, these signs are different, and these signs are different. The last two signs in both of these formulas are always the same. Now, when you're looking at this, if you're dealing with a sum of cubes, the first sign is plus in our formula, and then the second sign is the opposite of that. If we are dealing with subtraction, well, the first sign is then subtraction, and the second sign is the opposite of that. So you might want to have these formulas written down. Now, the next thing you want to consider is if there's three terms, then you want to go ahead and do your AC factoring. And then if there's four terms, then you want to go ahead and do grouping. Now, down here, we have four terms. But the first thing you'd want to see is, do we have anything we can pull out of all the terms? Well, they don't all have B's, so we can't pull any B's out. And when we look here, I'm looking at the 6, and only 2 and 3 go into 6, but neither one of those go into 7, so we don't have a greatest common factor that's going to help us. So we're going to group. We're going to look at what can we pull out of the first two. And I can go ahead and pull out a 7, and so I'm going to look at the greatest common factor, and that's a 7 and a B squared. And then I'm going to go ahead and look at what would be left in here. And that would be a B and then a 7B squared times what would be that 49B squared, and that would be a 7. And then I'm going to look at the last two. What can I pull out of the last two? That's a minus 6. And then I'm going to go ahead and look at what would be left if I pull out that minus 6. And that would be a B and then a plus 7. Remember, a negative 6 times a positive 7 gives you that negative 42. Now, with factoring, you're on the right path if both parentheses end up being the same, which it is. That's like your greatest common factor. So you're going to pull out that B plus 7, and then you're going to go ahead and look at what's left. Well, before or from the first part, we're only going to be left with the red. And so I'll bring that down. Now, when we pull out that blue minus, or B plus 7, the blue part, from the second part, we're only left with that green minus 6. And then this is how you factor by grouping. Now, once in a while, you'll come across a situation where one of these parentheses would go farther yet, but in this case, it doesn't. And you might be wondering, well, this one here is two terms being subtracted, and we have our B squared here. Yes, it could potentially be differences of squares, but you'll notice our red 7 is not something squared, nor is our 6 something squared. So we can't do anything to it. This is just our answer. So as we look here, we always look for our greatest common factor first. What can we pull out of this? Well, everything has n's, and so I'm going to pull an n out, and then I have two things subtracted, so I have to have a subtraction sign here, and then you got to think n times what is n squared, and well, that's an n, and then you got to think n times what is a 9n, and that's a 9. Everything now is to the first power, so we can't really do anything more. Sometimes when you pull out your greatest common factor, you can take things farther yet. When we look at problem number 16, over here on the right, you want to look at your greatest common factor. Well, what can I pull out of all this? They all have a v, so I'm going to pull out a v and then write what's left. A v squared minus a 2v minus a 15. Now you notice in the parentheses we have three terms, so then you want to do your AC factoring. A is what's in front of your square root term, which is this. C is that last number. So then you go A times C. So for us, it would be 1 times negative 15, which is negative 15. You now want to look for what multiplies together to give you negative 15, like a negative 1 and a positive 15, but would add together to give you this. Well, those don't. I can try a negative 3 and a positive 5. Well, those add together to give me a positive 2, not a negative 2. So it's really just having to switch those signs around, and it would be a minus 5 and a positive 3. So I'm going to bring down my greatest common factor still. I'm going to bring down that v squared, bring down that minus 15, and then instead of writing this, I'm going to replace it with a minus 5v and a plus 3v. So what I put here in red really is the same as this right here. So I haven't changed anything in my problem for the value, but it does look different. Well, then we'll bring this down. All we'd have to do is factor by grouping, because in our parentheses we have 4 terms. So you look at, well, what can I pull out of here? A v, and then you're left with, if you can see it, a v minus 5. And then you go ahead and you take a look at what can I pull out of here, and I can pull out a positive 3. And then you want to look at what you're left with. Well, you're left with a v minus 5. Now remember, if the parentheses are the same, when you're grouping, you're on the right track. So I still need to have my greatest common factor. I need to then pull out my common factor here, which is the black, the v minus 5. And then you want to look at what's left. Well, I'm left with that 1v in the front, and then I'm left with that plus 3 over here. And that's our factoring of this. Start with greatest common factor. We had 3 terms, so we did AC factoring. Once you find the 2 factors that add together to give you that middle term, then you have rewrite it and you have 4 terms, and it's just that factoring by grouping again. On the lower left here, we're going to start out with our greatest common factor. You always want to look for that greatest common factor. And we get this. Now, when we look at this, we have 2 terms that are subtracted. So you want to see, is it differences of squares or differences of cubes? Well, our m is squared, so it's not going to be the cubes. Now we have to write it as something squared minus something squared. So you got to think, is 49 something squared? Well, 49 is a 7 squared. So I'm going to still bring down my greatest common factor. When you're dealing with differences of cubes, our formula says when you rewrite it, both parentheses are pretty much the same, but one of them is plus and one of them is minus. Then you have to ask yourself, what's in the beginning that's being squared? Well, that's an m, so I'm going to put an m in the beginning of each parenthesis. And then you need to look at the end. What's in the end that's being squared? And well, that's a 7, and that's a 7. Now, I've seen a lot of people not rewrite our problem so it looks like this, and then they mess up what they actually need to put down below. Take the time to rewrite it as something squared minus something squared. So we're going to continue here. Here we have no greatest common factor. We have an n squared minus it would be a 3 squared. So it's differences of squares. So then rewrite it, one with a plus, one with a minus. Then you look at yourself, what's being squared in the beginning? That goes in the beginning of each one. What's being squared at the end? That goes in the end of each one, and that's it. Now, over here, this is really sum of squares. Now, sum of squares is not one of our options here. So there's nothing we can do. So this is prime. Because remember, from normal numbers, if it doesn't factor, we call it prime. Lower left here, problem number 36. Remember, we always start with our greatest common factor. We're going to pull a 2 out. Then, in the parentheses, we're left with two things being subtracted. And so it's a p squared. I'm thinking it might be differences of squares, and you need to then think, okay, is 4 something squared? Well, that's a 2 squared. So we're going to go ahead and factor this according to differences of squares. Remember, one of the parentheses is plus, one of them's minus. It really doesn't make a difference. What goes in the beginning of each parenthesis? Well, what's in the multicolored line that's being squared at the beginning? Well, that's just a p, so p goes in the beginning of each one. Then you look back up over here. What's in the end that's being squared? Well, that's just a 2, so I'm going to put a 2 in the end of each parenthesis. So we're going to continue to look at these special cases. Now, here, I'm going to go ahead and look at this and say, oh, I have a plus. So it makes me think it might be this right here, the sum of cubes. And before that, you'll see I have something cubed. After that, I got to think, okay, is this something cubed? Well, a 2 times a 2 times a 2 is that. So now I can go ahead and rewrite it with my formula here. So, with a plus, and then I have to have something squared, minus 2 things, and then plus, and then something squared again. So now, your a right here is what's in the beginning that's being cubed. Well, that was our x. So each a down below I need to replace with an x. Now, my b down below in my formula is what was being cubed. Well, that was my 2. So each b in my formula I need to replace with a 2. And now I'm going to just go ahead and simplify it a little bit. So can't really do anything here. I'm going to just go in x squared, and then I don't really need the parentheses around the 2 and the x, so I'm going to go minus 2x, and then plus, and then 2 squared here at the end is just 4, so I'll just write it like that. Now, I'm going to go ahead and take this and bring it down below, and we'll work this one out. This one is, you always look for greatest common factor. There isn't anything here, but we do have 2 terms subtracted. And you'll notice we have a cube, so I'm wondering if it's this one here, differences of cubes. So first of all, you need to start off as writing it as something cubed minus something cubed. When you are looking at the 64, if you know it, great. If not, maybe take the cube root of this on your calculator and you'll notice it's 4. So a 4 to the 3rd power is our 64. And then what's beforehand, you need to think, okay, what am I cubing here of this whole thing to give me the 125m cubed? Well, it'd definitely be an m. And if you don't know it for sure, since we're dealing with cubes, take the cube root of 125, and that's 5. So then we can rewrite our formula here. And your a right here is what's in the beginning that's being cubed. Well, that's our 5m. So I'm going to put a 5m for each one of those a's. The only thing you have to be concerned about is this part right here. That squaring applies to the whole a, so I need to have this extra set of parentheses here. And now your b is what's at the end that's being cubed. Well, that was just our 4, so I got to replace all my b's with a 4. Now, here I don't need an extra set of parentheses because I only have one thing that's being affected by my exponent. So now I'm going to go ahead and simplify. Now, when I'm looking here, it's a 5m times another 5m, so it's a 5m squared. Then at the end, a 4 squared would be a 16, and then I'm going to have this for my answer. So, side note here, which one of these two fractions at the top can we actually cross out the 9's? Now, if you're adding the same thing top and bottom, that's not a special form of 1, so you cannot cross out those 9's. But multiplying the top and the bottom both by the same thing, that's really like a 9 over a 9, and timesing by 9 over 9 is really multiplying by a special form of 1. You can cross out the 9's. So it's important to note you can cross stuff out, top and bottom, if it's multiplied by the top and multiplied by the bottom. Now, when we look down below here, we could not take a 10 out of here and here because it's not 10 times the top and 10 times the bottom. But we could go ahead and factor it. Remember, in factoring, you always look for greatest common factor. Looking at the top, we could pull a 10 out of the top, and we'd be left with a 3a minus 7. You'll notice you can take a 10 out of the bottom. That's your greatest common factor. And you're left with a 5a plus 9. Now, since we have a 10 multiplied by the whole top and a 10 times the whole bottom, we can actually cross these 10's out and look at what's left. Now, just be aware, you cannot do anything between your 3 in front of the A and your 9 on the bottom because it's not 3 times the whole top. And we can't do anything with the A's because it's not A times everything on top and A times everything on the bottom. On a problem like this, you want to let X represent each one of your answers. Now, because our problem says integers, that means normal numbers, no fractions. In the blue, I'm going to multiply both sides by 3 to get rid of my fraction. And so I get a 3x is equal to a minus 2. Now, in the blue and the green, to finish this, we need to have it, our variables on one side, and then set equal to 0. So in the green, I need to subtract a 6 from both sides, and I would get an x minus 6 is equal to 0. And then in the blue, I'd have to add a 2 to both sides, and I get a 3x plus 2 is equal to 0. These two things that are set equal to 0, you have to have them set equal to 0, are the two things that you actually put in your parentheses to multiply together to get your equation, because we need an equation that says equation a couple of times. So what was the blue was equal to 0, we put that down, and the green we'll put down in here. Now, we can tell from looking at our problem that we know we're not done because we don't have it left with parentheses. So all we have to do down below is just do our double distribution and get rid of our parentheses, and then we'll be done. And then you'll notice that we have some like terms here, so I'll bring those together. Put my like terms together from here. Negative 18 of the x's plus 2 of the x's is negative 16 of the x's, and then we're done.